Recording in progress.
Jangan ragu. Kami punya banyak hal di sini. Segala hal yang dibutuhkan untuk mengembangkan dan pengelolaan segala sumber daya alam serta lingkungan yang luar biasa, agar bisa bermanfaat bagi masyarakat banyak. Segala hal yang dibutuhkan untuk membangun kota-kota modern. Infrastrukturnya, jangan
Recording in
ragu.
progress.
Kami punya banyak hal di sini. Segala hal yang dibutuhkan untuk mengembangkan dan pengelolaan segala sumber daya alam serta lingkungan yang luar biasa, agar bisa bermanfaat bagi masyarakat banyak. Segala hal yang dibutuhkan untuk membangun kota-kota modern. Infrastrukturnya, serta semua yang mendukungnya. Para tenaga ahli pun siap mendampingi para anak bangsa menggapai cita-cita setinggi langit. Bersama dengan literasi yang juga luar biasa. Karenanya, jangan ragu. Bersama kita pasti bisa menggapainya.
Good morning once again, distinguished guests, honorable speakers, participants, and college. Welcome to the International Conference on Innovation, Engineering and Sustainability 2025, proudly organized by the Faculty of Engineering, Pakuan University. My name is Winda Widya.
My name is Yusi Febriani.
It is our honor to be your master of ceremony for today's conference. Let us begin our event today with gratitude and enthusiasm.
Before we begin our seminar, let us start the event this basmala. For those who are Muslim, please join me in reciting Bismillahirrahmanirrahim. May this session run smoothly, bring benefit to all of us.
To begin our program, let us participate respectfully as we begin the Indonesian national anthem, followed by the Pakuan University hymn. Ladies and gentlemen, please rise.
Kebangsaan Silih asih, silih asah, silih asu menjadi ciri rasa kebersamaan, wangi dan saling mewangikan. Jayalah Universitas Pakuan untuk kejayaan bangsa Indonesia.
Thank you. Next, we invite Dr. Lilis Sri Mulyawati, Master of Science, Dean of the Faculty of Engineering, to give her welcoming remarks. Please welcome Dr. Lilis.
Bismillahirrahmanirrahim. Okay, can you hear me?
Yes,
Yes.
Teacher Lilis, please, Teacher Lilis.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
warahmatullahi wabarakatuh.
Good morning, distinguished guests, ladies and gentlemen. It is an honor and privilege for me, on behalf of the Faculty of Engineering, Universitas Pakuan, to welcome all of you to International Conference of Innovation, Engineering and Sustainability, ICONES 2025. Allow me to extend my highest respect to our distinguished keynote speaker, Professor Blian Yuliarto STM Eng PhD, Minister of Higher Education, Science and Technology of Republic Indonesia. Distinguished speaker, Mr. Hua Seng Huang, PhD from Sun Yat-sen University, Guangzhou, China. Dr. Chih Yi Liu from Mingchi University of Technology, Taiwan. Associate Professor Dr. Siti Hajar binti Misnan from UTM, Malaysia. Professor Cheng Hanbao, PhD from Tianjin Research Institute for Water Transport Engineering, Tianjin, China. Senior Dr. Muhammad Sahmi bin Muhammad Said from UITM, Malaysia. Director of Universitas Pakuan, Profesor Dr. Rear Paul Insinyur Haji Didik Noto Sujono MSc. The Vice Rectors, the Deans, and Vice Dean of all faculties. Head of Study Program and our esteemed lecturer, representative from government, industries, academic institutions, and research communities, and all participants joining ICONES 2025. First of all, let us express our gratitude to Almighty God for His blessing that allow us to gather here today in a spirit of collaboration and innovation under the inspiring theme, Sustainable Infrastructure, Smart Cities Bridging the Gap between technology and community. Distinguished participants, the theme reflects on of the greatest challenge of our time, how to design and build infrastructure and cities that are sustainable, inclusive, and human-centered. Smart cities are not only about automation or artificial intelligence. They are about connecting people, enhancing quality of life, and ensuring that technology serves humanity. ICONES 2025 is envisioned as a multidisciplinary platform uniting experts from civil engineering, electrical engineering, geodesy, geology, and urban planning. By sharing knowledge and research, we can bridge the gap between technology, innovation, environmental, and social responsibility. Ladies and gentlemen, in line with the vision of the Faculty of Engineering, University of Pakuan, to become an excellent Faculty of Engineering with the values of Silih Asih, Silih Asah, and Silih Asuh toward the ASEAN Reference University 2035. We are deeply committed to advancing sustainable engineering that are locally rooted yet globally impactful. On this occasion, I would like to express my profound gratitude to the ICONES 2025 Organizing Committee, especially Mr. Wahyu Gendam as a steering committee, and our distinguished speakers, industry partner and collaboration institution, and academic community of Universitas Pakuan, who have worked to make this conference success. Thank you very much. Most importantly, we extend our deepest appreciation to Professor Brian Yuliarto STM Eng PhD whose vision and insight enrich the conference with a profound perspective on how technology can truly bridge with humanity and community. To all participants, let us embrace this forum as bridge connecting discipline, linking generation, and uniting nation in the pursuit of sustainable innovation. Let us affirm that engineering is not merely about machine and system, but about creating a better, fairer, and more livable world. May this conference inspire collaboration, research, and action that lead us to sustainable and better future. This is the end of my speech. I hope we can take a good lesson from that, what I delivered today. Thank you very much for your attention. I'm sorry for any word unpleasing you. Engineering greeting. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Lilis. Let's give a warm round of applause.
Now it's our great honor to invite the Rector of Pakuan University, Profesor Dr. Rerum Politicarum, Insinyur Haji Didik Noto Sujono, Magister Science, Insinyur Profesional Utama, Asian Engineer, APEC Engineer, to deliver his opening remarks and officially open ICONES 2025.
Okay, thank you very much, this Mr. Moderator. Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asrofil anbiya wal mursalin wa ala alihi washabihi ajma'in. Assalamualaikum warahmatullahi wabarakatuh. Honorable Mr. Minister of Higher Education, Science and Technology of the Republic of Indonesia, Professor Brian Yuliarto, ST, MN, PhD. Honorable speakers, Mr. Wang Sheng Huang, PhD from Sun Yat-sen University, China. Professor Dr. Chi Liu Yu from Minxin University of Technology, Taiwan. Associate Professor Dr. Siti Hajar binti Misnan from University Technology, Malaysia. Professor Chen Hamdao, PhD from Tianjin Research Institute for Water Transport Engineering, Tianjin, China. Dr. Muhammad Sahmi bin Muh Said from University Technology, Mara, Malaysia. Honorable Dean of Engineering Faculty, Dr. Insinyur Lilis Sri Mulyawati, MSc, and all of Vice Dean. Honorable Head of Study Program and Head of Committee of this event, Mr. Insinyur Wahyu Gendam Prakosa, MSc, distinguished guests, moderator, esteemed colleagues, and participants from around the world. Good morning and welcome to the International Conference on Innovation, Engineering, and Sustainable 2025, which was initiated by Faculty of Engineering, University Pakuan. It is of honors of the privilege to open this important event hosted under the theme Sustainable Infrastructure and Smart Cities, Bridging and the Gap Between Technology and Community. Today, we gather of a diverse community of innovators, researchers, engineers, and leaders dedicated to advancing sustainable development and shaping the future of the urban environment. Our cities are growing rapidly and facing challenges to demand innovation solutions that are not only technological advantage but also deep connected to needs, culture, and value of the communities they serve. This conference marked the significant opportunity to explore how smart city technology and sustainable infrastructure can work hand to hand to create inclusive, resilience, and efficient urban space to enhance the quality of life for all citizens. By bridging of the gap between cutting and edge technology and community engagements, we move toward to future where development is not only innovative, but also equitable and sustainable. Over the next few days, we will hear from the leading experts, their strength groundbreaking research and foster collaboration that will inspire to new strategy and solution. Together, let us seize this chance to learn, to connect, and innovate for the sustainable city of tomorrow. Thank you for being part on the collective journey. I wish you productive, insightful, and inspiring conference. By saying Bismillahirrahmanirrahim, the International Conference on Innovation, Engineering, and Sustainable 2025 with the theme Sustainable Infrastructure, Smart City, Bridging, and the Gap Between Technology and Community is official opens. Thank you very much for attention and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor. Let's give a warm round of applause.
Ladies and gentlemen, now we move to the keynote session. We are honored to welcome our keynote speaker, Professor Brian Yuliarto, Bachelor of Engineering, Master of Engineering, Doctor of Philosophy. Let's give a warm round of applause.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Distinguished Rector of Pakuan University, Professor Dr. Didik Noto Sujono, MSc, Distinguished Dean of the Faculty of Engineering, Dr. Lili Sri Mulyawati, MSI, distinguished invited speakers joining us from across the globe, Huaseng Huang, PhD from Sun Yat-sen University, China, Dr. Muhammad Sahmi bin Muhammad Said from University of Technology, Malaysia, Associate Professor Dr. Sri Hajar binti Misnan from University Technology, Malaysia, Professor Chen Han Bao, PhD from the Tianjin Research Institute, China, Dr. Chi Yi Li from Ming Chi University of Technology, Taiwan. It's an honor to address the International Conference of Innovation, Engineering, and Sustainability 2025. Today, we gather to discuss an issue central to our shared future, sustainable infrastructure and smart city, bridging the gap between technology and community. Ladies and gentlemen, urbanization is accelerating globally. By 2050, nearly 70% of the world's population will live in cities. The rapid growth creates pressures on infrastructure, resources, and the environment. Yet the true challenge is not only technological, it's the gap between innovation and the community it's meant to serve. A city is not smart simply because it has sensors, data centers, or advanced network. A city is smart only when the technology improves people's life, when it reduces inequality, enhances safety, strengthens resilience, and supports environmental sustainability. As Minister of Higher Education, Science and Technology, I emphasize that research must have purpose and innovation must have impact. Engineering today cannot remain siloed. Civil engineering must integrate resilience and green materials. Electrical engineering must deliver smart, low-carbon energy systems. Geodesy and geology must guide safe, land-sensitive planning. Urban planning must be human-centered, inclusive, and participatory. From my academic perspective in materials and sensors, I see enormous opportunities: self-healing concrete, structured health monitoring, air quality sensors, digital twin, smart grids. These are not abstractions. They are tools that can help cities become safer, cleaner, and more efficient if they are accessible and understood by communities. This is why human-centered design is essential. Technology succeeds only when citizens can use it, trust it, and see its benefits. Smart cities require not just digital infrastructure, but social infrastructure, education, digital literacy, and participations. To our students and researchers, do not stop at laboratory success. Bring your innovation to the field. Let rural areas benefit from the renewable energy solutions. Let local leaders understand your mapping tools. Let communities shape the urban system they will live in. To our international partners, Indonesia welcomes collaborations. With its diverse geography, Indonesia is a living laboratory for sustainable and resilient solutions. In closing, building sustainable smart cities is not a race of technology, it's a journey of collaboration between scientists, engineers, policymakers, and communities. I hope ICONES 2025 will produce real partnerships and practical solutions that strengthen the future of our cities. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Biran, from the insightful keynote speech. Before we move to the next session, let's capture this memorable moment with a group photo session in Zoom platform. Everyone, please turn on your cameras and smile. We'll take from the first screen. Okay. 1, 2, 3. Okay, next to the second screen. 1, 2, 3. Okay, the third screen. 1, 2, 3. Okay, the fourth screen. 1, 2, 3. Okay, and next. 1, 2, 3. Okay, next. 1, 2, 3. Okay, next. 1, 2, 3. Okay, and next. 1, 2, 3. Okay, next. 1, 2, 3. Okay, 1, 2, 3. Okay, last one. 1, 2, 3. Okay, thank you.
Okay, ladies and gentlemen, we will now proceed the moment we have. We have been waiting for ICONES 2025 seminar. Allow me to introduce our moderator for the session. Our moderator is Dr. Ryan Nurtiawan, STMT, who currently serves as a lecturer in remote sensing at the Faculty of Engineering, Department of Geodesy, Pakuan University, Bogor. He completed his doctoral degree in Geodesy and Geomatic at the Institute Technology Bandung. He also has extensive experience in radar remote sensing. He completed this throughout his career. Dr. Ryan Nurtiawan has led various geospatial and the land acquisition project, delivered talk in academic and professional forum, and accredited research in digital mapping, remote sensing, and spatial data analysis. He is also intensively involved in professional communities related to geospatial science and regional development. With his strong academic background and professional experience, he is highly qualified to guide our discussion today. Ladies and gentlemen, please welcome our moderator, Dr. Rian Nurtiawan, STMT.
Thank you very much, Mrs. Yusi and Mr. Vinda. Thank you very much, Mrs. Yusi and Mrs. Vinda. My name is Rian Nurtiawan, and I have the honor of serving as the moderator for this event. Good morning, everyone. It's truly a pleasure to be here with all of you today. I'm excited to guide our discussion, and I hope we can make this session not only informative but also engaging. Please feel free to share your thoughts, questions, and ideas as we move along. Your participation is what will make this session meaningful. Please note the question and answer session will be conducted after this third speaker presentation. Participants may submit questions via the chat box, and those wishing to speak directly are requested to use raise hand feature. Our question will be addressed during the Q&A session. All right, let's begin. Enjoy our time together. It is my pleasure to invite our first speaker, Dr. Huang Sheng Huang from Sun Yat-sen University, China, who will present a talk titled Tiny but Mighty Fossil Pollen to Reconstruct Environment and Biogeography during the Cenozoic. Before we begin the presentation, allow me to briefly read the curriculum vitae of our first speaker. Associate Professor at the School of Geography and Planning, Sun Yat-sen University, China. 2021 PhD Palynology and Biography, Institute of Biodiversity and Ecosystem Dynamic, University of Amsterdam, the Netherlands. Experimental skill: palynology, sample collection, preparation, and palynomorph identification, fossil leaf identification with architecture and cuticular analysis, fossil wood slide preparation, difference microscopical technique. Research interests: Cretaceous and Cenozoic vegetation, climate environment, and biostratigraphy, evolution history, and biography of plant, climate nice model, fossil database management. Now, I would like to invite Dr. Huang to begin the presentation.
Good morning. Can you hear my voice now?
Yes.
So let me share my PowerPoint.
Clear. Okay.
Clear, very clear.
Okay, very clear. Please.
I need to share my PowerPoint, and now I need. Oh. Sorry, just a moment. That I need to give authorization to the room to share
okay,
my screen.
Okay.
It's okay, Dr. Huang.
So that is okay. Actually, I have a slight modification to this PowerPoint, but I can also use this one. Firstly, I would like to give a brief introduction of myself. Please, next slide.
Okay.
So I got my master's degree in Chinese Academy of Science. So the topic is on the the southwestern China Pliocene environment in paleoecology based on the macrofossils. So that is more about the paleobotany. And then after my master's, I moved to University of Amsterdam in Netherlands and to work on the Myanmar Eocene paleo-environment and palm historical biogeography with Karina Hong and also Robert J. Morley. Maybe most of you or some of you know about Morley, right, Bob, which just visited your faculty maybe 2 weeks ago, right? And then after my PhD, I did my postdoc in University of Florence in Italy on the Pleistocene environment in central Italy, also with palynology as process. And then after that, I was a visiting researcher working on Cretaceous Pliocene bomite chemistry. Bomite is bone is amber, so it's a slight difference from palynology. And then after that, in January of 2024, I joined in Sun Yat-sen University as an associate professor and also a principal investigator of the InBio group. Next. Sorry, next slide. And my research group, the full name is Environment and Biogeography Research Group. So InBio, it means environment and biogeography. And we have 3 topics in our group. The first one is vegetation and environmental evolution during Cenozoic. So we use multiple processes and different approaches, including plant microfossils, including the phytoliths, the pollen, and also the charcoals to reconstruct Cenozoic diversity vegetation pyramid across Southeast Asia, China, and other regions of Asia. And the second topic is paleoecology and historical biogeography. This part we use the global fossil database, integrating with the climatic niche models and also paleoclimatic niche models to check the historical biogeography of some key taxa, for example, the palms. So for the first and the second topics, I hope we can have more communication, for example, the academic communication and also the student exchange between Sun Yat-sen University, my lab, and also with Pakuan University and the Faculty of Engineering. The third one is about the bomb is amber chemistry, so I will not talk too much about this. Now, in my group, we have 1 postdoc, 2 PhD students, and 4 master's students, and 3 bachelor students. So after the MOA that's signing between Sun Yat-sen University and Pakuan University, I hope that we can have some Indonesia students to come to visit our university and also our research group. So please, next. So my talk today is about the palynology its implication to paleo-environment and biogeographical reconstruction, and then at the end I will give final remarks of my talk today. Next, please. So the first part is paleo-environment. Let's have a look at the research background. Next. So the research background, first, maybe some of you have known about palynology. The palynology is the study of pollen and spores, and the study of their morphology, classification, combination, evolution, and also their distribution patterns. So it includes the fossil and modern pollen and spores. That my research field is in the geological history And palynology is widely applied in stratigraphy, palybotany, paleogeography, and paleoclimatology, archaeology, and also medicine, maybe like forensic palynology. The pollen grains and also the pollen grains and the spores, they are very productive. In the following animation, you can see that the pie tree can produce many grains, and those pollen grains and spores are very easily deposited in lacustrine environments. So in lacustrine environments, usually it contains lots of pollen and spores. Next, please. Well, so why we need to look into the deep time palynology? For the first, the left side figure, you can see the Asteraceae in the Middle Eocene of Patagonia of South America, which was published in Science, is the earliest Asteraceae fossil record, and also combining with other evidence that we can check is biogeographical history. And also the other figures are the phytales, but my new PowerPoint, which I cannot share now, that also includes the other pollen grains. For example, the Dipterocarps. The Dipterocarps pollen grains that was found in Maastrichtian of Africa, of Sudan. Also is also the evidence of the earliest Dipterocarpaceae fossil records. So in deep time that we can know atmospheric carbon dioxide concentrations, that, and also we know that maybe some of you know that Jacob's paper in 2007, and also the latest paper about the carbon dioxide curves in 2020 by Westerho. So we know that the atmospheric carbon dioxide and also the temperature, they both decrease through the Cenozoic. So as now we are talking very much about the global warming, and in the early Eocene, the temperature is up to 15 degrees Celsius, higher than present date. So we can use these results to model the future scenarios. So the deep time records can offer key insights into vegetation responses, past and also future global changes. The next slide, please. And now is about the paleovegetation in fossil pollen and leaves. More about pollen, we can see that from the left figure that during 92 to 83 million years ago, the South Pole, the Antarctic, is not so cold. It had temperate rainforest dominated by podocarpus. Podocarpus, you know, is temporary rainforest components. So with pollen process and also the leaves, you know, the right side, the figure in the right side shows Middle Eocene lowland mid-subtropical Sangrila ecosystem in central Tibet. So with those botanical processes, we can reconstruct paleovegetation. And also the next, please. We can also use fossil pollen to reconstruct paleoclimates. We usually use the mutual climate range of different taxa. We use the nearest living relative method. We assume that climatic tolerances of the fossils are very similar to those of their nearest living relative. And this method becomes more accurate in younger fossils. But in the meantime, problem can arise if fossils are not of the same origin. For example, that for pollen, some pollen taxa, for example, Pinus can transfer through like several hundred kilometers. So we need to be careful on this kind of reconstruction of paleoclimate. The next slide, please. So the topics of my talk today is related to peri-environmental and also geographical reconstruction. The first one is peri-environment. So I will mainly talk about the Myanmar, the Burma, right? The Burma, the continental Southeast Asia. That is also the topic of my PhD project, working with Bob, Robert J. Morley, and also Karina Hong. So the Eocene is about 56 million years ago to 33.9 million years ago. And you can see that in my PhD project, I focused on the late Eocene of the Central Myanmar Basin. The age is about 37 to 36 million years ago, evidenced by paleomagnetic reconstruction. And we know that in the Eocene, the temperature is much warmer. And also in the right figure, you see that the latitudinal gradient is less pronounced. You can see that in the ECO, in the right figure, you can see that the rainforest range was very broad, but only a few terrestrial records from the tropics have been reported. Please, next slide. And here you can see that my research site is located in northwestern Burma or Myanmar, just like about 100 kilometers away from the border between India and Myanmar. And you can see the sampling sites in C, and in B you can see that in the Eocene, the Burma terrain. So the Asian Myanmar is not located as so northern as the present date. You can see that the southern part is located at the equator, and you can see that the vegetation is moist deciduous forest and dry deciduous forest, and the climate is tropical savanna climate and also humid subtropical climate. The next, please. And my research questions in this slide contains three. Please, the next one. The first one is about the floral composition of this Palina flora, and also its implication about the India-Asia plant dispersals. And the second question is about the reconstruction of vegetation, climate, and plant diversity change in this time period of this region. And the third question is about the depositional environments derived from sequence biostratigraphy in this region. The next slide, please. So this is about the materials and methods. You can see that we collected the samples along the river because we don't have like very good during records. That's very expensive. And I did the lab analysis in University of Amsterdam. And then the scanning electron microscopy was carried out in University of Vienna. Due to the time limitations, the approaches, I will not spend too much on this. So the approaches include the bioclimatic analysis, the BA, and also the reflection analysis on the diversity of 4 tropical Eocene palinofloras, and also the sequence biostratigraphy. Let's have a look at the conclusions. of this part. So the next slide, please. Next, please. So we can have a look at the conclusion one. We can see that for those you don't know the palynology of pollen grains, you can see that the top right figure that we have the light microscopy and scanning electron microscopy images of a new genus, the one that is tricoperate pollen grains, and also the artistic pollen grains with different colors. So we found that this flora is very diverse, dominated by ferns and also palms, for example, the calamus, the nipah, and also mainly Nipoides and Calamoides, and also Sapitaceae. You know, Sapitaceae is lowland forest tree taxa, and also other taxa. So these taxa are typical for lowland evergreen forest. And you can see that the bottom left figure, they have different level of landscapes. Like for example, the coastal, the lower deltaic plain, that they are mainly coastal forests and mangroves, and in the middle part is upper deltaic plain, and then upstream area we can see seasonally dry deciduous evergreen, Piedmont and montane forest. The next slide, please. So this slide show you that the diversity of the pollen grains and also some MPP, non-pollen polynomials, some algae, and also some other like dinoflagellates, and also some other taxa. The next slide, please. And this show you mainly the scanning electron microscopy image. So you can see that ornamentation of different pollen grains, they are very clear. And the right figure, you can see the palm pollen grain ornamentation. You can see that their ornamentation, they are very detailed. You can see that, right? So the next slide, please. And now here you can see that the landscape, the detailed landscape reconstruction with combination of sedimentology. So we found that this flora is the result of plate collision, like the Asia-India collision and the monsoonal climate. So I will talk about the monsoonal climate later. And we proposed that Myanmar was a close loss for plant dispersals between Laurentian and Gondwana. You know, Laurentian, the Asian southern plate, and the Asian northern plate. According to the summary of some key taxa, their range distribution across the stratigraphical chart you can see on the right side. And the next slide. So we reconstructed the paleoclimate, and we recognized 6 vegetation zones, and we used bioclimatic analysis and found that the Central Myanmar Basin was cooler and drier than at present. You can see that there are 3 dry wet packets on the top figure. So on the bottom figure, you can see that there are 6 vegetation zones. And the next, please. The rarefaction analysis results suggest the Central Myanmar Basin has the second highest richness and evenness. So this could be due to the Indo-Asian region as well as its near equatorial position. You can see that in the previous figure. You can see in the Eocene, the Central Myanmar Basin is close to the equatorial position. It's about 5 degrees northern, and the highest and the Palinoflora that has the highest richness and evenness is the Watupulu Palinoflora, Indonesia. You know that you can see that in A, from the top to the bottom, the third one, Watapuru section, that was carried out by Dr. Iko Lelono, that was previously Bob Morley's PhD student. So it has the highest richness and evenness. So this could be due to the polyhumid climate in the Eocene, in the late Middle Eocene. Next, please. And for the depositional environment, we detected a change from a tidal influence actually to a fluvial setting without tidal influence. By clustering different palm composition, you can see that in A, the Dicopolis, its affinity is calamus. So you can see that from the bottom to the top, the percentage increase. And this taxa indicates the region environment. We can see that is changing to a fluvial settings. And the next, please. So the second conclusion about the depositional environment, we use the ICS coastal on lab. We also use the system chats. So our team, including Bob, so we found that the change of this environment is due to the changing sea level, which also drove depositional sequences. It's very interesting. If you are interested, you can read our paper published in Geoscience Frontiers. And next, please.
Dr. Huang,
So
3 minutes
yeah.
remaining.
3 minutes. Okay. Yeah. I had lots of things. So that's about the biogeography and fossil pollen, that we know that by the dipterocarpaceae, this is the use of fossil pollen to reconstruct the biogeography story of dipterocarpaceae. And the next one. So next one is about the podocarp forest is also used fossil records. We need to skip. We need to switch to the next slide, please, because of time limitation. The next, please. So we use palms as model group because it has lots of fossil records. Yeah, this one and next one. Late Cretaceous, very abundant. Next slide. So we found that during the Eocene or Oligocene transition, it has a drop. So that's the resource background. And the next one. And the next slide, please. And the next. Well, our research questions are the diversity and biogeographical history of palm trees over the geological time. Yes, the next. Next, yeah, we use global pollen record database, lots of varied fossil records, more than 1,000 fossil records. And the next one, yeah, we use the climatic niche model simulation and diversity analysis. The next, please. Conclusion. Yes, this is, I have already talked about this. Next one. Yeah, we found that India is a hotspot for palm diversity in the Paleogene. And next. Next, please. Yeah, the Mediterranean palm, we also have a biogeographical history for this lineage. Next one. Yeah, this is the pleasant distribution and also the artistic pollen image for this lineage. The next one. Yeah, the stratigraphical range charts and also polymaps that can lead us the results that biogeographical history of this taxa was influenced by global cooling in during EOT. And next. Oh, and the divergence of maritime predates previous studies by at least 10 million years ago, 10 million years. Next, please. So by combining the pollen record database and the climatic niche model, we found that in the Sinoyoic, most of Calamoidy and Nipoidy decline in diversity of and geographical range, and the regions could be the cooling and drying after the Oligocene. You can read our paper in Global Ecology and Biogeography, published in 2021. Yes, the next one. Outlook, we need to have more fossil records like leaves, seeds, and foods. And also we need to use new methods like Bayesian analysis that we are collaborating with the collaborators from Sweden and also Switzerland to look for this. The next, please. And the final remarks, the EOT, you know that there's a cooling during this time transition. So next. Oh, yes, it's not clear. So I hope that we can have more sites in Southeast Asia, like Indonesia, in the central or western, in Western Indonesia. And next. Yes, more taxa, like rhododendron, Calophyllaceae, Castonopsis, for this biogeography. Yeah, and next, maybe there's still a few slides. Yeah, that's rhododendrons. And next. Please, maybe 2 seconds. One slide that I can. Yeah, this is the rhododendrons that already summarized by my PhD students. And next. Also the diversity history of this taxon. Next. Sonoratia, the mangroves, we are also working on it. And next. Yeah, also Sonoratia. Next. And this is Castanopsis. I think the last slide, sorry. So we're also working on the fossil records is modeling. And then the last slide. Thank you very much. So I would like to thank my collaborators from different countries, and I hope that we can collaborate in the future with the Faculty of Engineering, Pakuan University. So if you have any questions, you can contact me by my email again, or later. Yeah, thank you very much, and sorry for the delay and the issues caused by my settings of the Zoom. Sorry.
Thank you very much, Dr. Huang, for the insightful and enlightening presentation. Ladies and gentlemen, please join me in giving a warm round of applause.
Thank you.
Ladies and gentlemen, we will now proceed to our second presentation. It is my honor to introduce Dr. Muhammad Sahmi bin Muhammad Said from University Technology Mara, Malaysia, who will speak on the geometrical technology in spatial data management and mapping. Before we begin, allow me to present a brief curriculum vitae of our speaker. Senior Lecturer, Studies of Surveying Science of Geomatics, School of Geomatics and Natural Resources, Faculty of Built Environment, University Technology Mara. PhD in Geomatics 2021 to University of Glasgow, United Kingdom. Area of expertise, cartography, map usability, public transportation mapping, hydrographic surveying, offshore surveying, GIS, and geovisualization. Now, I would like to invite Dr. Muhammad Sam bin Muhammad Said, please.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Can you guys hear me? All
Waalaikumsalam
clear?
warahmatullahi wabarakatuh.
Clear,
All right.
please.
Thank you so much,
Very clear.
Dr. Rian,
Good.
our moderator for today. I would like to thank you, all of you, distinguished guests, my sahabat-sahabat semua dari Universiti Pakuan, and our fellow surveyors here. Okay, it's an honor for me to present my talk today at ICONES 2025. My name is Muhammad Syahmi bin Muhammad Said from the Department of Surveying Science and Geometric, Faculty of Built Environment, UiTM Shah Alam. Okay, can you share my slide? Okay, great. All right. All right. I want to begin today by acknowledging a collective challenge that we face in managing our cities. Our current maps, our data simply are not keeping up with the reality. While we deeply value the foundational work of mapping and surveying, but we too much relying on the static 2D documents in managing complex and fast-changing data can create a serious risk. So my talk today is dedicated to showing you how we move past this limitation. We will explore the key technologies from advanced scanning to spatial AI that will allow us to transform our cities from a collection of static documents into a responsive, predictive, and socially aware digital twin. So as you can see from the slide, my title for the talk today is Static Maps to Social Twins, Advanced Geometrics in Spatial Data Management and Mapping for Future Cities. We are trying to transition from documenting past modeling into anticipating futures. So in this transformation, we still value the fundamental part of surveying, which is geodesy. So we need accurate reference frames, we need GNS monitoring, we need deformation tracking, and reliable graffiti model to form the backbone of the smart cities. So without this geodetic precision, the model that will be developed will not be reliable. Okay, so over the next 30 minutes, I will guide you through these three pillars. Previous slide, please. Before. Not this. Earlier. Another one. Okay. So let me begin by confronting the problem. As you can see from the figure that I show in the slide, despite our advancement, the vast majority of data, the vast majority of global infrastructure is still be managed using 2D maps. So this metadata on this file often reads last updated many times ago. So as you can see from the right, the live map, this is the reality of the cities we live in. It's a dynamic, moving, and breeding organism. The traffic flows in the cities is changed by minute. The structures in the cities degrade by millimeters, and communities keep evolving. So this gap between the city that exists and the map that we use to manage the city is what I call the static blind spot. We are attempting to manage 21st century hyper-connected data with 20th century data cycle. So this disconnection is very inefficient and quite dangerous. Okay, next slide, please. So this blind spot can have several consequences. So I highlighted three of that. The first one is delay detection. The second one is chronic efficiency, and the third one is acuity failure. So if we miss the first part, delay detection, we will miss critical structural failures. The second one, without real-time data, we cannot simulate the dynamic loads. So we might be over-engineer or misallocate resource because we are guessing a pattern. We doesn't rely on the advanced data that we have. And the third one, acuity failure. If we have we have faced the first two factors, the third one is inevitable. So we will most critically mask the inequality. Without any special data, the changing needs of vulnerable communities remain invisible to high-level planners. Next slide, please. So the solution to overcome all these factors, we need a fundamental paradigm shift. This is how we view geomatics. We must stop viewing our profession as a method of taking inventory only. Simply just counting, cataloging, collecting data that we have. We must start viewing our profession as a method of generating intelligence, understanding behavior, and predicting what we need. We are moving from what is here to what is happening here and what will happen next. Right, next slide. So as I said, there are three pillars in this topic. So the first pillar, from static maps to the the new social intelligence, is sensing. So this is close to our surveying profession. The first fundamental paradigm shift is sensing. This stage is entirely dedicated to establish the digital truth. How can we get the correct data? We are moving beyond simple flat maps in X and Y position into a comprehensive four-dimensional reality. Crucially, this foundation requires the science of geodesy, the precise measurement of Earth size, shape, and gravity. So geodesy will ensure our data not just correct in X and Y position, but also in the vertical elevation, the Z value. And another vital dimension that we need to add is time, T. So we need to have a four-dimensional data, X, Y, Z, and T for time. Next slide, please. All right. So in sensing, in geomatics, we can have a lot of sensors, but in today's talk, I will highlight only three of that. Okay. The first one, we can see the mobile LiDAR, which is considered a high density point cloud. The second one is UAV photogrammetry, which come in the form of real-time autophotos and DSM. And the third one is remote sensing, Earth observatory. Yeah? Okay, next slide, please. Okay, I go on to give more detailed information on mobile LiDAR. So among the sensors that been available to us using geometric studies is mobile LiDAR. As you can see in the visualization, LiDAR doesn't just take a flat photograph, it captures a dense and measurable point cloud. We are talking here about millimeter level accuracy captured at a very high speed. With this, we can see that we don't just see a bridge or any structure, we can measure the deflection of that structure. We can monitor of the subsidence of any structure day by day. We can move from a sparse manual sampling to a continuous reality capture. This provides the geometric fidelity required for a true geospatial analysis. Next slide, please. Right, the second sensor is UAV photogrammetry. As you know, satellites, we can get data using the sensor from satellites, but satellites provide coverage that often too broad or obstructed by the clouds. So we also have LiDAR that can be quite precise, but restricted to many other constraints, especially the financial part. So we have here drone using UAV photogrammetry to fill the gap. So with drone, they give us on-demand agility, the keyword is agility, whether it's mapping a disaster zone hours after a flood or tracking daily stockpile volumes on a construction site, drone can provide the temporal resolution that we need. Okay. They allow us to update the map with drone. We can update the map with in conjunction for the speed of the project, not the speed of our annual survey budget. Right, next. So the third sensor that I will tell here is about remote sensing. So remote sensing gives us the macro view, but a modern remote sensing right now can give us not just the view, but can go beyond the visible spectrum. For example, by analyzing thermal bands over decades, we can track slow-moving, invisible threat like the urban heat island effect that I show in the screen. This provides a long-term baseline data essential for climate resilience planning. It tells us how the city is interacting with its environment over the decades. Okay, next slide. Right, so that's the first part, the first pillar, which is sensors. So next, we go to the next stage, to the next pillar, which is synthesizing. So right now, in the first part, we have sensors, we have captures, terabytes of data, a lot of data. But all the data without any structure is just a noise. It's just useless. So we need this second pillar, which is synthesizing. This is where we build the brain of our application, our smart cities. Or we can also produce the urban digital twin. Okay, next slide. So this is the fundamental part of a digital twin. A digital twin is often misunderstood as a just pretty 3D model. It is much, much more than that. You can see from the diagram there, it is the convergence. It is the operational fusion of three distinct data environment. The first one, data that we get, we convert into GIS, and then we can convert it into BIM, Building Information Model, and we can add value to the data using IoT. So the convergence of these three distinct data environment can create one common data environment, or we call it SCDE. If any one of these factors is missing, the twin is incomplete. Okay, next slide. So we go to the first component, GIS. So with GIS, GIS provides the context of our data. It answers where is our data, where is the location. It defines the spatial topology of our data. For example, it tells us that a pipe can connect to this treatment plant, can connect to this water treatment plant. Or this road connects to other main roads, connect to this other highway. Okay, with GIS, it provides the framework and the relationship between the assets. Right, next slide, we move to the next component, the BIM. So what is BIM? BIM give information about what? If GIS give information to our data about where, BIM give about what? BIM stand for Building Information Modeling. BIM can turn a simple geometric box of data into one intelligent asset. It tells us the material properties of column. It tells us the material of that box, its load capacity, and any type of data that can be related to that box. So it brings geospatial fidelity into the map. Right, next slide. Next component is IoT. So we in our data, in our digital twin model, we have GIS that give data about where, and then we have BIM that give information of our data. And right now we have the path of our data using the Internet of Things, IoT. So with IoT, without IoT, our digital twin model is just like a digital archive data. It's like a museum only. But with IoT, it gives us the path, gives us the living life of our model. Okay, the IoT provide real-time sensors monitoring air quality, traffic flow, and any other structural vibration that breathes life into the static model that we have. All right, thank you. Next slide. All right, so all three components needs a brain. Okay, so here comes the artificial intelligence that we are currently being exposed. Okay, so the brain in this model is what we call GeoAI, Geospatial Artificial Intelligence. So we are using AI to move from simply describing the past. Okay, for example, we have a pipe broke here. To predicting the future. Okay, like this pipe will break in 2 weeks. This pipe will break in 1 week, so on and so forth. Right. So using GeoAI, we can do a much more practical application like predictive maintenance. We can combine it with the use of convolutional neural network (CNN), so our system can automatically scan any data that we have and detect the anomalies. So that's why I said that with GeoAI, it can predict any pipe burst, any pipe break in the future. Okay, we can identify infrastructure failure weeks before it becomes catastrophic. Okay, this shift our entire geometric engineering model from just a reactive repair to more proactive care. Right, next slide. All right. But all this intelligence isn't just about the hard things, not just about the concrete. It's also about the people. We must use the GeoAI for helping us in equity scenarios. So, like in the simulation I shown in the slide, here I model a flight event. Okay, a standard geometric engineering will look only at the water level, but with GeoAI, it will look into the impact. We can overlay the flood model with other vulnerability data that we get. For example, like age, income, person disability, and so on and so forth. Okay. So if we use GI, we can, the GI then will combine all the data, process it, synthesize it, and create one anomalies. For example, we can see the red building there. So the red building will identify exactly who is most at the risk, and we can prioritize our flood defense, our flood resource to protect them first. So this is the geometric engineering we are looking for the social justice. Right. Next slide. Right after we have sensed the data, we have synthesized the data. Here comes the third pillar. Okay. Perhaps this is the most important pillar. Okay. Socializing. So although we have the most advanced technologies, it is meaningless if it remains locked in our surveyor office only. So we need to bridge the gap between the technology and community. We must make the data accessible for all the people. Next slide, please. Next slide, please. Okay, we can socialize the data by democratizing it. We are moving away from complex technical blueprints that alienate the public. Okay, the people cannot understand what we have done in the previous two pillars. We can use web GIS, we can use interactive visualization to let people know what the planning impacts right on their own smartphone. Very simple. We can turn passive residents into active, informed participants in the planning process. With citizen science, or we call it volunteer geographic information, VGI, this can enable residents to give the data back to us after they use our application. They can report issues such as pothole, outage, flooding via their own mobile device and send them to us. We can turn the citizen into a human census, another census of data for us. So this is crucial for equity because it fills the critical data gap that is undeserved or informal settlement that any of authorities might miss. It gives the community a voice in the data. Right, next slide. All right, another aspect that these pillars highlight is the geospatial deserts. So the ultimate goal of socialized data is identifying any geospatial deserts. Look, we can look at the grid on the screen. So the red cells represent areas that are systematically undeserved by essential service, like transit, healthcare, or green space. So by using network analysis to calculate actual travel time, we can make this inequality visible and quantifiable. We can shift the planning metric from just a simple density to a true accessibility, forcing accountability in how we allocate our resources in general. Right, next slide. All right. In general, in my conclusion, the transition from static maps to social twins creates a new mandate for every professional in our discipline. We must design special system that is prioritize resilience, equity, and also collaboration. Our special system must go through instant adaptation and 4D monitoring, must go through transparent metrics that ensure fair resource distribution, and must go through continuous feedback loop with the people that we serve. We are not just here to building maps. We are building the operating system, the OS, for our smarter and fairer world. Next slide. As geomatics and engineering professionals, Our responsibility today extends far beyond producing maps and managing the assets. We are now the chief architect of special intelligence, designing the digital foundation upon which our cities will stand. With the powerful fusion of geodesy, with the fusion of LiDAR, GeoEye, IoT, and any other type of survey disciplines, we are equipped not only to make cities smarter, but to make them more resilient, more inclusive, and more human-centered. Thank you for your attention, your passion towards our discipline, and your commitment for shaping the cities that are truly serve their people. Together, we are not building not only better maps, but a better and sustainable future. Thank you so much. Terima kasih.
Thank you, Dr. Sami, for the clear and insightful presentation. Ladies and gentlemen, please join me in giving him a warm round of applause. Ladies and gentlemen, we will now move on to our third presentation. It is my pleasure to introduce Associate Professor Dr. Siti Hajar Binti Misnan from University Technology Malaysia, who will deliver a talk titled Humanizing Smart and Sustainable Cities, Reimagining Housing, Governance, and Community Resilience in the Post-Carbon Era. Before we proceed, allow me to briefly present the CV on our third speaker. Town Planner, Associate Professor and Head of the Department of Urban and Regional Planning at the Faculty of Built Environment and Surveying, University Technology Malaysia. PhD in House Economics from the Department of Building and Real Estate, the Hong Kong Polytechnic University, Hong Kong. Primary research interests encompass into institutional analyzing, housing study, and low carbon cities. Actively engaged in both national and international effort to advance institutional framework, housing policy, and sustainable low carbon cities, contributing through academic research, consultancy project, and policy advocacy. Now, I kindly invite Associate Professor Dr. Siti Hajar Binti Misnan to begin her presentation.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Everyone can hear me clearly?
Waalaikumsalam, Dr.
Warahmatullahi wabarakatuh.
Clear, very clear.
Clear.
Go ahead.
Very clear.
Alhamdulillah. Selamat pagi. Good evening. Good morning, everyone.
Morning.
And we proceed with the presentation. And next from me, can the secretary share my slide? So I take this opportunity to thank to the organizing committee of International Conference of Innovation, Engineering and Sustainability, ICONES, to welcome me as a speakers for today's session. To all honorable speakers, distinguished guests, and moderators, students, academia, and participants. Can the secretary share my slide?
No. Okay, please wait.
Oh, I share.
Sorry, Doctor.
The slide from Dr.
Mana-mana boleh?
Siti or yeah. From me, operator. Oh.
It's okay. I think I can share. You okay?
See.
I share my screen.
Not yet appear.
Yes.
Yes. Yes, I can see. Go ahead, Dr. Siti.
Yes, clear.
Okay. So
Go ahead,
everyone
Dr.
can
Siti
see my
Hajar,
first
please go.
slide?
Yeah. Okay, clear, very clear.
Clear.
Okay, good.
Hey.
The title of my presentation is Humanizing Smart and Sustainable Cities, Reimaging Housing, Governance, and Community Resilience at the post-carbon era. And I can reflect back to my previous journey as academia and also involving in research and consultancy related to carbon. And back to 2016, there is a lot of study research focusing on low carbon city, and afterwards it goes to the introduction of climate action cities, and the latest one, most of the cities all around the world, and especially in Southeast Asia and Malaysia, they are now focusing on net zero. At the same time, for the last few years, there is a growing intention in applying not only sustainable but smart cities. And so I interested to share with you today with this topic. This is the content of my presentation. It consists the overall urban planning evolution back to from 1990s to 2025, what happening to us in Indonesia and in Malaysia. And after that, I go next to the humanizing smart and sustainable cities, smart cities in Malaysia and the way forward. So it is good, I believe, to share with all of the participants that joining the session today to look at from the urban planning evolution, how actually the urban planning itself shape together with the community, with the human needs. It begins from the early 20th centuries where most of our town developed under the themes of aesthetic, monumental design with the urban reform. We can see during that era, there is a lot of York's art, city beautiful movement that emphasize of grandeur, aesthetic and monumental architecture to create an inspiring civic places. So what happening to Malaysia during that time is influenced by British colonial planning principle, emphasize on segregate land use, infrastructures, development and administrative centers, focusing more on resource extraction and colonial economic priorities. And in Indonesia, it's under the colonial Dutch influence significantly shaped urban development, particularly in Jakarta. This design reflected in the administrative center, military zone, and also segregated residential area. What happening next to the mid-20th centuries? This is where we can see from 1950s to late 1970s, they are the introduction of more modernism, functionalism, and segregation of automobile defense, where we can see that modernist planning is more advocate for functional city layout. There is a zoning law and high-rise housing introduced to our city. So this is relates to the prominent theories from the Corbusier utopian radiant cities. And we can see it's happening in Malaysia and also Indonesia, where the city widening the traffic and suburban expansion, focusing the shift towards highway, automobile accessibility, and suburban sprawl. So we can see that in Malaysia, there is introduction of new cities and satellite cities such as Petaling Jaya, Putrajaya. And in Indonesia, we can see that urban development heavily influenced by the central planning and often centralized with the top down, such as Jakarta expansion itself. And what happening at the late 20th centuries, there is a critique on the way how the modernized planning happening. where the committee come to engagement and involvement, and they wanted to promote more sustainability. So daripada sini, and from this era, we can see that people, the committee already shift towards not only modernism, but they try to promote more sustainable development. So this is where the recognition of urban problems, how to solve the problem, the introduction of smart growth, a new urbanism, and the participatory community-based planning, where community try to increase and emphasize on stakeholder involvement from bottom-up approach. And so in Malaysia, we can see this apply under our National Development Plan, um, which is, which is the what we call it here in Malaysia, RMK, and we currently we are under the RMK 13. And in Indonesia, urban planning increasingly focus on decentralization, post-1980s democracy reform, and the rapid urban sprawl and informal settlements happen and become a major concern during this time. What happened in the millennia, the early 21st century? The themes and the growing towards sustainability, resilient and social equity, and smart city is become more, give more intention from the local players and from the authorities and also government. It's focusing on the sustainable development and how to integration of the technology and to the city development. We can see that during this era, this is the introduction of GIS, how to use the big data and the smart city concept to enhance the planning and management. So what happened in Malaysia is it began to emphasize on sustainable urban development, the introduction of smart city and the green technology. And in Indonesia, it also emphasized on tackling and handling disaster resilient, climate change adaptations, specifically on the Jakarta flood control and sea level rise strategies. And in Indonesia, it also have a major infrastructure project, and such as Jakarta-Bandung High-Speed Rail, and also regional development plans under Mandalika GPN. And what happens now in the recent development from 2020s to 2025, this is the era of what we can call it the digital cities and climate adaptation and inclusive growth. I have the opportunity to see the changings before this because in UTM and Malaysia, we have a low carbon Asia Research Center, where we work closely with the local authority to calculate the carbon emission for certain cities and to come up with the climate action plan that how to mitigate and how to adapt to the current situation. So under this movement, this is where I share with you just now the movement from low carbon city and towards a climate action change, and then now is more towards zero carbon and net zero. And at the same time, more city in Malaysia now talking about smart city. And so the focus is more on smart city initiative, digital transformation, and climate resilience. And similar to in Indonesia, there is a massive infrastructure investment, and the urban resilient initiative such as Eco City concept and focus on reducing urban inequalities emphasize on sustainable development. So in a conjunction to that, we can see that the movement now not only focusing on climate action plan, how to mitigate and how to adapt to the current climate change impact, but most of the cities in Malaysia and all around the world is now promoting smart and also sustainable cities. So what actually relates to the harmonizing smart and sustainable cities is referred to the concept of designing urban environment that prioritize the needs, the well-being, and the engagement of people while also incorporating smart technologies and sustainable practice. So we can see that in order to achieve harmonizing smart and sustainable cities, we can apply two main things which is we need to make sure that it's come from human-centric design. It focuses on the human. The design of a space need to give a priority to the human that this can create more economic consideration and create such as a workable street, public space, park, and more into community-centric design. And the community engagement is important here, and in order to come up with their own needs and their what is their appreciation and what actually they want, and for making their cities more aligned with what the citizen preferred. And in Malaysia nowadays, we also promoting what we call it uh, plan tindakan PTK, plan tindakan khas ataupun or a special area plan where it's the plan is imposed for a short term period where it can be executed within 1 to 3 years, but at the same time it needs to engage with the community, with the local players in order to make sure the plan and the project can be done and can be executed within the time period given. The second thing is the smart technology integration must also include together with the human-centric design, where here the information of data, the big data, the data-driven solution is important to utilize smart technologies such as IoT, device, big data, and to enhance the process of analytics and to improve the urban service. Also give impact and influence to enhance the livability of the cities. And so now I move to the third part and what actually happening in Malaysia from the shift of the climate action plan, net zero, to the introduction of smart city in Malaysia. The flows is actually happening together, but at the same time, the smart city in Malaysia now is represent as a new approach to urban management through the use of technology and address urban challenges. So the definition of smart cities, it's the cities that use the information and communication technology and advanced technology which address to address the urban issues and challenges. What is our current urban issues and challenges can be addressed by the smart cities. Second one is to enhance the quality of life, economy, and environmental sustainability. And the third one is to ensure the effective of and efficient urban management. So I share with you here the example of how we can apply smart city. And the first picture showing the natural-based solution, which is the retention pond that serve as a flood reservoir. This can give a positive implication to the mitigation and adaptation to the climate change. But at the same time, how to impose the smart and technologies to the similar approach, we can include the technology-based solution by using analytical CCTV or sensor and to monitor water level rises and flooding. And this sensor or CCTV can also give a signal and warning, early warning to the resident and to the community to stand by and to get out and to remind them that the water level increases. And so it's give ample time to the resident to move and to seek, find the shelters before flooding happening. And at the same time, one of the other example how we can apply a smart city to the our environment. We know that all street we have street lamp, and most of the street lamp is controlled by what we call it timer, which is when the time change when the timer setting to 7 p.m. and the light will on, it will on. But in order to identify whether it's smart or not, the timer is not sufficient yet to achieve the technology and smart city level. So in order to make sure that the street lamp is imposed and applied using a smart city element, it need to be um, arranged and it need to be put with the sensor where the time begin darker, and so the lamp will automatically on, and it is what happening during the daytime and also the nighttime. And by having that sensor is particularly can support the smart city initiative. So the smart city in Malaysia, it needs it become a more urgent need nowadays and to overcome urban challenges, to implementing global and local agenda, and to make sure that we are following the current policy to make our cities more competitive. It also a state of art of technology, and to show that we try to use the technologies, the big data, AI, to help make decision based on analytic data driven. So we can see now the town planners and students that learning urban planning not only need to understand the urban issue and need to understand what actually the community needs, and they also need to know now how and what are the data related and how we can use this data to embed using technologies and to make decision. And last but not least, the smart city, to become a smart city world class, this is important, and from Malaysia perspective, to prepare a city in Malaysia towards smart city through given the cities in Malaysia a smart city rating to be comparable at the international level. So in Malaysia, we have what we call it Rangka Kerja Bandar Pintar Malaysia or Malaysian Smart City Framework 2019 to 2025, and currently Malaysia in the process to come up with the Malaysia Smart City Blueprint 2040. And under the Malaysia Smart City Framework, there are 7 components, the 7 cores and components to support Malaysian smart city strategies, covering smart governance, smart economy, smart people, smart living, smart mobility, smart environment, and smart infrastructure. So these 7 framework align with the indicators by smart city components. These indicators used to measure and to rank the city in Malaysia using all these 7 pillars, which is the first one, the smart economy. It has 6 indicators, and the highest one is the smart environment, covering 32 indicators. And in total is 85 indicators for achieving smart city for the city rating in Malaysia. And it is also interesting to see that to achieve the smart city, there is a smart city measuring journey where the cities can apply and for the city rating for the level 1 smart city early adopter. This can take times from 1 to 3 years. And then for the second one, level 2 developing smart city. And level 3 leading smart city. This another phase where the cities actually not only applying for the level, but they need to progress to the next step. And from smart city early adopter, for the next years after this, they can apply for developing smart city, leading smart city, and towards the final level for visionary smart city. So this is the target for the Malaysian cities, so that by 2040, most of the cities in Malaysia not only promoting not only promoting sustainable city, but they are also already implement most of the indicators under smart city. And this is how the level 1 up to level 4 indicators recognition under smart city in Malaysia. And this is the Malaysian Smart City Rating Program, which is most of the local authority in Malaysia nowadays trying to apply. At least they already now applying for Smart City Early Adopter. And the way forward, the last part of my presentation is the strategy towards promoting smart city, the integration between the whole committee under the local authority, how to achieve towards smart city early adopter. Of course, the PBT themselves, the local authority, they need to sit down together with all stakeholders. They need to identify which of the indicators the local authorities already achieved, so that they can submit to the report and applying for the smart city early adopter. This is the target from Malaysia government, where by 2025, they hope that 63 local authority already at least apply and receive smart city early adopter. And by 2030, 93 local authorities already covering the rating 1 as smart city early adopters. And by 2040, most of the 156 local authority already been a smart city. I'm happy to share with you this year, 2025, all PBTs in Johor, 16 PBT under the state of Johor already at least achieving the rating 1 as smart city early adopter, and one of the cities which is Majlis Bandaraya Johor Bahru, the main cities in Johor already achieved level 3. So this is will give a good impression and reflect to Johor, the state of Johor, as it become the first smart state in Malaysia. So I'm also happy because the academia, the stakeholders is one of the supporting towards the achievement and completing the report and submitting the report together with other stakeholders in the PBT. So I welcome everyone to come to the state of Johor and to learn from their application on promoting and applying for smart city early adopter. And what next is the government is not only focusing on the cities at the local authority um, stages, but now they go towards smart township rating and try to recognize property developers that implement integrate smart city initiative at urban development at the township level. And there is a lot of potential township to be recognized and to be acknowledged under the smart city initiative in Malaysia. And the second one is we are also going towards the smart institutions where most of the higher education institutions in Malaysia, such as 20 public university, 435 private university, and so on, can also applying for smart city rating. And even some of the higher education public university, they already have their own smart city, smart sustainable campus blueprint to promote smart city in the campus. As my overall conclusion of the today presentation, I would like to share might be some of the factors, successful factors in terms on how Malaysian promoting a smart city. The first one is focusing on smart city planning. The second one, smart partnership, where the commitment towards collaboration between government, industry players, startup entrepreneurs, and innovators is very important. And so far is supporting each other, one another towards the smart city implementation. Public participation also important to ensuring the implementation of smart cities towards people-centric smart city. The use of technology such as open data sharing, integration for the benefit of all parties. I believe that this is one of the most challenging part, but from for the past 5 years, we can see that now most of the agencies understand and they can see that the importance on how sharing the data can also helping us managing the cities and giving us more opportunity to solve urban problem. Number 5, the data sharing integration. It coverage speed and quality for smart city development. And last but not least, the digital infrastructures nowadays is more implemented, especially at the new cities, the big cities in Malaysia, covering the IoT, cloud computing, big data, and it's also promoting in the university level and also at the school level in Malaysia. So I believe that's all of my presentation today. Once again, thank you for the today's session. And I also would like to wish a happy 45th anniversary to University Pakuan. And all the best to all my colleagues at the Faculty Engineering at Pakuan University. Thank you.
Thank you. Terima kasih Profesor Dr. Siti Hajar for insightful and thought-provoking presentation. Ladies and gentlemen, please join me in giving her a warm round of applause. Ladies and gentlemen, we will now proceed to the question and answer session. If you have a question, please raise your hand or type your question through the platform provided. For clarity, kindly state your name and institution before asking your question. Okay. The first question from the Fahri M. Zuhri, please.
All right. Thank you for the opportunity. So let me introduce myself. My name is Fahri Muhammad Zuhdi from Civil Engineering Universitas Pakuan, Indonesia. So I would like to appreciate all the speakers for sharing our presentation and insight. Thank you very much. And then I believe that every speakers have background for environmental studies. So I would like to know about how your opinion or how do you see or assess what happened recently in Indonesia, especially for what happened in Sumatra Island, which is a catastrophic flood caused by extreme weathers. And I believe it also occurred in some part places in Malaysia, in Kangar, if I'm not mistaken. So how do you see your, I mean, like, how do you assess this crisis? And also, how your respective countries may be like what kind of mitigation strategies or maybe can what kind of implementation from smart cities that can be implemented into anticipate this crisis. So I guess that's all. Thank you.
This question for the for to Dr. Siti Hajar, right?
Yes, I can begin to answer the question. Um, I first of all, I see that the catastrophic happening in Sumatra is very sad to see that's happening to the people, which is they're not ready with the sudden cyclone that happening to the Sumatra and also to the Malaysia. Uh, I believe that not only in Malaysia but in Indonesia, the government have already strategy and also ready with the mitigation and adaptation of the climate change and especially the flooding happening at a certain area. Contohnya di Malaysia, example in Malaysia, we already have NADMA, the agency that have their own plan and to always stand by. They know that the season, monsoon season coming, they stand by and all the agencies from the higher level to the local community level, they already stand by for that. At the same time, by using technology, we can see nowadays, for example, the latest cyclone that happening, the government in Malaysia already give a warning, early warning to all community who are living at the lower ground and lower area to stand by and that to stand by that the cyclones coming in the next 2 days, and that's I believe one of the reason why less numbers of casualty happening in Malaysia compared to Indonesia. But at the same time, we also need to understand that the cyclone coming to our area is not normal and something that not we are expecting. And this is why it's give a big impact, especially to the area that before this there is no flooding, there is no big flooding happening, and I can see that there is something tragically happened to the area that not ready with that kind of catastrophic. In future, there is based on experience in Malaysia, they are now also observing the terrain the higher ground that have contohnya macam apa ya, ada pengumpulan air di atas bukit. So itu that's the area where most of the agencies they are monitoring this to make sure it is stable or not, and to give a early warning if the big monsoon are coming later into the area. Or maybe there's other feedback from other. That's from me. Thank you.
Thank you, Dr. Siti Hajar. How about Mr. Fahri? That's all? Okay. The next question, please, Keisha Salimar. Introduce yourself and what from your institution. Please, Keisha Salimar.
Thank you for sharing such valuable insight. I'm Kesia Salimar from the Urban and Regional Planning Study Program at Pakuan University. In your opinion, what is the most critical aspect of sustainable infrastructure that cities often overlook when trying to modernize their system?
Okay, please respond this question.
Yeah, maybe
Please,
I can
Dr. Siti.
respond first. Yeah, from our experience in UTM, University Technology Malaysia, the learning and the introduction of smart city just begin last few years. I believe that a lot of talks, sharing talks about smart cities happening last year. And when we talk about smart city, we encourage agencies to share their information, their data that can be run into the system and can generate the outcome, the prediction what happening to the cities in future, so that we can prepare in advance. But at the same time, when we discuss a lot about promoting smart cities, encourage people to learn how to use technologies, I really agree with you that to prepare the infrastructure is much more important. Kalau kita belajar saja tapi infrastrukturnya tidak ada, for example, at the city level itself, they didn't have any infrastructure to supporting good internet. There is no infrastructure to provide 5G, 4G, 5G. And in order to monitor the traffic, and in order to monitor the sea level rise, for example, if there's no facilities provided, if there's no CCTV, if there's no sensor, how that actually we can come up with the data projection. This is where we can see the budget and the preparation for infrastructure is much more important in order to support smart city. Otherwise, we can talk about smart city, we can encourage people sharing information, but at the same time, it cannot be applied as the cities not stand by with the infrastructure. I agree with you that the cities need to have their own strategy, and I can see that this is what happening in the state of Johor. The government, the state government of Johor, they spend a lot of money. They also encourage investor to come in to help in the investment of the smart city. That's why one of the things that nowadays being talked a lot is the emergence of lot data center in Johor Bahru, and there is a lot of other international technology company. They wanted to build their own platform here in Johor. That's from me. Thank you.
Thank you, Dr. Siti Hajar. For the next question, please, Dr. Helmi. Please, Helmi. Mrs. Helmi.
Thank you.
Yeah.
Thank you, Mr. Rian. I would like to answer a question about the Mr. Huang. I get the answer. So it's my answer is to Miss Siti Hajar.
Please.
It's
Go ahead,
several
Mrs.
things
Helmi.
do you explain about the stage of the smart city. I hope that's what the challenge might arise when integrating smart technology into urban planning while keeping the city human centered. Thank you.
You mean the challenges while the local authority applying for the smart city rating, isn't it? Okay. I attending several focus group discussion at the local authority level in order for them to complete the form and to submit for the smart city rating. I do agree it's not easy even to achieve the level 1 smart city because according to the indicators, the local authority, the cities themselves, they need to identify whether they already fulfill each indicators under the first tier 1 smart city rating. So they need to provide the evidence and showing that they already implement all the indicators under first tier smart city ranking, and then they also need all the cities. They also need to have their own smart city strategies plan towards promoting smart city. So during the discussion, I can see that local authority themselves not able to fulfill the smart city indicators alone, and they need to work together with the community. Even most of the time, they need to also refer to the other stakeholders who are currently in their boundary of the cities. And so they will discuss with the commercial area and with the industry stakeholders, with the others agency, and whether they have that kind of smart city element and to be supported under the ranking. And so this is one of the challenges, but at the same time, we also can see that states of Johor are able, all the 16 PBTs, they now already achieving the first ranking, and some of them already go to the second ranking, and one of the local authority already go to the third ranking. So I believe that by looking at that, we understand that the cities that now move the second ranking and third ranking, they are more proactive. Not only the local authority, but they work together with the stakeholders and community. It's a big challenge. They need to invest some amount to promote smart city and to implement technology in their cities. That's from me. Thank you.
Thank you, Dr. Siti. I will be continue question from chat column. I will to show by slide this question. Question for Dr. Muhammad Sami bin Muhammad Said.
Okay, thank you,
Question one.
Dr. Ian.
How does the integration of GIS, BIM, and IoT contribute to building an urban digital twin that support real-time decision making? From the Muhammad Mahfud. And the second question, why is 4D data from mobile LiDAR, UAV photogrammetry, and remote sensing essential for improving infrastructure monitoring and risk mitigation? And third question, how can the concept of geospatial district help government enhance the quality of public services distribution in urban areas? Please, Dr. Muhammad Sami.
All right. Thank you, Dr. Rian. So, and thank you, Pak Mahfuz, for the question. For the first question, how does the integration of GIS-BIM and IoT contribute? So, the keyword for this question is about supports real-time decision making. So, GIS and BIM provide the model, provide the background data, not in real time, but here the key aspect in providing real-time decision making is in the IoT lah, the Internet of Things. So we need to get that IoT sensors to work in in a good way, in a good functionality, so that the IoT can contribute back to the fundamental aspect of GIS and BIM. So we need all these three to work together. Without one parameter, the division in real time cannot be concluded. And then for the second one, the second question is about why the 4D environment is important. Okay, in any application of smart cities, we need to get this data, and the important thing is to get all these 4 dimensions of data in a accurate way lah. Okay, we can have a lot of modeling, a lot of data model, a lot of flood modeling, for example, but if at the first place the 4 dimension of data is not in the good quality, all our model that been created is not good lah. Okay, it's not applicable lah. For example like for the flood modeling lah. Okay, if at the first place we get the data, we get the X, Y, Z and T data from a bad sensors or from bad quality data from low resolution data, so it will result to a non-accurate flood modeling lah, flood modeling model. So if we do the analysis and the flood still happen, still affected the critical area, so we need to check back our the quality of data that we get in the first place lah. So that's the important, that we need to do it right at the first time when collecting data and structure our data set. And again, the third question, can I of geospatial deserts enhance the equity? Okay, so geospatial desert is the other name for data gap lah. So we need to rectify the gap. We need to know the gap. So if we didn't find the gap, if we didn't see the gap clearly, so that's why it will affect the public service resource, public service action that can be that we can source to the actual problem. So with all this integration of GIS, BIM, IoT, with all the data, it will help us to identify the gap, identify the deserts, just geospatial deserts. Alright, so with that, after we can rectify it, then the public service distribution will be much more smooth, much more efficient. All right. Hope that all answer my that's all answered the question.
Thank you, Dr. Sami.
All right.
Due to the time limit this session, ladies and gentlemen, allow me to summarize the key point and insight delivery by our speaker. From Dr. Hua Seng Huang, palynology and the palynological fossil record provide important insight into the biogeography and diversification history of palm, the maritime substrate, and important lineage of palm in the CMB during the ICONES. In the term of data and technology integration and biography, this will include other fossil records such as leaf, seed, and fruit, combined with the use of new methods such as Bayesian analysis to analyze the origin and evolutionary history of palm. From Dr. Muhammad Sami bin Muhammad Zaid, the transition from static map to social twin represents a major leap in how we understand and manage cities. With advanced geometric and combined GIS representing Internet of Things, IoT, and real-time analytics, urban decision-making become more accurate, responsive, and human-centered. This innovation will guide the development of future cities that are smarter, more resilient, and more sustainable. From Professor Dr. Siti Hajar, this presentation describes the evolution of urban planning from the colonial era to the digital and sustainability era, comparing Malaysia and Indonesia in terms of spatial planning, technology, and policy. The concept of harnessing smart city and emphasis as the paradigm that places people the center of urban development with the technology as supporting tool. Malaysia has developed a comprehensive smart city framework and indicator to drive the transformation towards smart national 2040. Future development direction include cross-sector planning, multi-stakeholder collaboration, strengthening digitalization, and development smart area and smart institutions to strengthen community resilience and quality of life. Okay. Ladies and gentlemen, we will now proceed to our fourth speaker. It's my honor to introduce Prof. Chen Haonbao, PhD from the Oceanography Research Center at the Tianjin Research Institute for Water Transport Engineering, China. Before we proceed, allow me briefly present. Graduate from Zhejiang University in 1993 and received his PhD in Port Coastal and Offshore Engineering from Tianjin University in 2014. Currently, the director of the Marine Hydrodynamic Research Center, the director of the International Science and Technology Cooperation Demonstration Base of Waterway Green Construction and Disaster Prevention, and the visiting professor of Weihai University and Shanghai University of Science and Technology and Master Tutor. Chen Haonbao PhD has long been engaged hydrodynamic and relative professional research with a solid theoretical foundation and professionalism. Now, I kindly invite Professor Chen Haonbao PhD to begin her presentation.
Okay. So thank you. Also, I'm very happy. So just your conference. So in Indonesia, also I have visited Bogor. So about 7 to 8 years ago. Yeah. So very beautiful city. Yeah. So okay. So now I just share my presentation. So can you find my presentation? Yeah. So okay. So ladies and gentlemen. So good morning. Selamat pagi. So also it's for lunch time. Yeah. So I'm Chen from China.
Selamat pagi. Good morning.
Ya, ya pagi.
Selamat pagi.
Ya, selamat pagi.
Siap. Thank you. Thank
Okay,
you.
yeah.
Selamat
So
pagi.
today I will introduce one type of solar energy, so named the floatable floating the PV, FFPV, yeah, which can be used in lake, lagoon, bay, and the sea. So especially in Java Sea, So Java Sea also is with the small wave and also very big just the area, yeah. So firstly, so I would like to introduce our institute, Tianjin Research Institute for Water Transport Engineering, so named TIWT. So belong to the Ministry of Transport. So our research field, so including river, coastal, and ocean hydraulic. So measure for river and seaport. TIW is also the top one institute for water transport in research in China. Yeah. So just over the past the 50 years, so our institute is celebrated just from 1974. So today, so also is already 50 years old. So our institute has supported over 100 major national projects and studies, yeah, such as the new Gorge Channel, new Three Gorge channels, and also about the bridge from Hong Kong, Zhuhai to Macau, the bridge. So our work spans over 90% of China coastal port and navigation rivers. And also through our international science and technology cooperation base. So we have just made 4 giant research centers. So as China, Indonesia, and also China, Bangladesh, and to the UAE and also the Africa, Ghana, yeah. So we have just build the country to country, the cooperation, so research just the base. So undertaking over 400 engineering studies and also across more than 40 countries. So this picture shows my footprint. So as the bright blue, the color, so means so I have also just visited and also have the work about their engineering and other the science, just the research. And green color is I have visited, but never work. Yeah, never have the work. And the dark blue so is work, but never visit. And also the gray is connect. So total is more than 50 countries. 50 countries. So I also think myself is the international person. Yeah. And our institute owns 24 the large scale the facilities for inland the waterway and also the port research. So here we have the world's the largest the large scale the wave flume. So with the long is 556 meter long and also 5 meter wide and to the 12 the meter just the depth. So here we can generate 3.5 meter just in the wave flume. So if with the scale 1 to 1, just 1 to 1 to 1 to 5 with the scale. So we can just simulate about 18 meter the wave, the very long wave, and also just to 10 meter tsunami, 10 meter tsunami. So also here we can generation the flow so of the 20 the cubic meter per second. So so these facilities cover from the marine the environment simulation to structure mechanics testing. So we also share these facilities international. So as just in last year, so we set a large flow alliance with more than 10 countries, including the United States, Germany, Japan, also Indonesia. Yeah. So today, so why we focus on the floating photovoltaic, just the floating the PV. So I think the one is just this is the solar energy. So it's the clean energy. Yeah. And the second is along just related with the floating structure. So it's about the ocean hydrodynamic, the research field. And also we just the research field also is the ocean hydrodynamic. Yeah. Three is there are lots of difficulties. So in floating the PV, so including the safety, the economic, and also the technologies. So in China, so local government are actively supporting the new energy. So as in August 2024, so in Shanghai, they issued the co-located wind and solar offshore the PV so development plan, the defining a high quality development path for offshore the PV. So in Jiangsu province, so also they have the 2025 to 2030 the plan, just the next 5 years plan. So focusing on project in offshore wind and also just the solar areas. And you know, in Guangzhou province, so they also have an action plan for future clean and low carbon, so industrial clusters. So the province not only calls for advancing the high efficiency PV technology, also they want just in the fast speed, yeah, of just to spread the offshore the floating PV, yeah. So many provinces, so just the local government want just to build the floating PV. Yeah. And also Chinese Academy of Engineering, so just the 2024, the global engineering frontiers, so have list offshore floating PV power generation, so among the top 10 engineering research frontiers in mechanical and also transport engineering. So similar with the offshore wind power. So now the solar energy is from nearshore fixed installation to deep sea the floating systems. Yeah. We add to all the world. So in regions such as in Europe and also Southeast Asia, so multiple startups have emerged focusing on the research and development, also including the application of offshore just the floating PV. So these pictures shows in Singapore, Norway, and the Netherlands, and also other countries offshore floating PV the demonstration cases. So also in Indonesia, so we have the floating PV is in lake just nearby Bandung. And we talk about the offshore floating PV, so have the obvious problem. So yes, it is wave. So wave is the big problem for the offshore the floating. So not only for PV and also for the wind power and others. Yeah, others. So we have 4 ways to just to solve the problem. So one is to find no wave area. So it's very calm and also as in lake, lagoon and other, so no wave area. And secondly is to build the black water, also including the floating black water. So just to make the sea area be calm. So as less to decrease the wave. And 3 is to make the structure defend the wave. So just have the force on structure in order to just the PV, yeah. And the final is make floating PV soft attached with the sea surface. So the 4 ways. So so the first we already to construct the floating PV. So in the lake, lagoon, and the secondary also is very expensive to build the black water and also the floating black water. And in China, several offshore PV projects is just select the way 3, just make the structure to defend the wave. So also we find it is expensive. And also now, so result seems not good. So here show just the 4 examples, but now 3 is destroyed by wave. So the first one is PIC. So the company, so they just constructed in Shandong province, this is 2022. So they make the 500 the kilowatt the thin film the type. So the investment is about 1.41 million US dollar. Yeah. So per watt is about 2.8 the US dollar. Yeah. And the second, also the same company SPIC. So they intending to build just 2 years ago. So that is 254 kilowatt, the tension floating accident type. So the investment is 0.45 million US dollar, and the cost is 1.44 so US dollar per watt. And just the last year, so CHN, the energy company, so they just have the construct in Jiangsu province. So there is 100 kilowatt. So this semi-submersible type, the investment is 0.62 million US dollar. So also the cost is 6.22 the US dollar per watt. And the new one is China Huanen group. They also built in Shandong last year. So that is just the 300 kilowatt. Also the same type. So the investment is 4.45 million US dollar. So that is the most expensive. Yeah. So here is 14.84 the US dollar per watt. So also you can find also all is very expensive. Yeah. So our group, so not select the wave 1, wave 2, wave 3, we select the wave 4. So I want to show you just show the video, show how about the wave 4. So it's about 1 to 2 minutes. So also we just recall very short the history of our FFPV, just the development and also the concept design and the test. So in the short video we find so in the large view balloon we have the test and also in the basin So so FFPV stands for the foldable floating photovoltaic. Yeah. So the TK also is a reference to TIWTE. So in Chinese word TK, yeah, TK. And from 30 years ago to present, so we complete the concept and the detailed design. So also achieved the 1-to-1, so the foldable prototype proof of concept in large wave room, and also 1-to-8 the scale. So we just to simulate the hydrodynamic layer test. Yeah. So in just our wave basin, so the basin the size is 40 meter the length, 3 meter wide, and also 1.8 meter the wave basin. Yeah. And this year, from July to September, so we complete, so just the C, so on site the test. So to just to test the structural safety and also, so other as the power performance. Yeah. So just also we have a plan. So just after all the test, so we next step just to last the 5 years. So this the left video is just the on site, so we can find just the bigger is the 1-to-1 is for the side testing, and the small one is just the 1-to-8 with the scale. Yeah. So first we just to test the safety, and also during with the testing we have the wave buoy to test the wave height on this on site. And from the prototype test, we just proved the technical feasibilities. Yeah. So from the night of September 16 to the night of September 17, so just this year, so you can find just the initial the condition which the blue alert just the level. That means here just the North Sea have the strong wave, So so our test the location is just at the top of the Shandong province. So just in the blue color. So here means also is the wave is strong, and just the left below so shows just the water surface the process, and the right so just we can find so the wave height. So just during the 24 hour so initial condition which is the blue alert area. So with the medium to large wave is 2 to 2.8 meter, and the wave buoys record the maximum wave height so close to 3 meter. So how about our FFPV? So during the wave is safe or be destroyed? So we can just also from video to find. Yeah. So this is the real-time monitoring, the capture both the distant and the close views of large waves. So the up video is just the distance, just the video. So we can just find, so is move just along with the wave, and the below video is the close video. So you can find just the movement. Yeah, movement under just the wave. So the wave is about 2 meter, and so if for just the 1-to-8 scale, so it also is safe here. So that means so for this the FFPV, so maybe we can just defend just to 8 meter, 8 meter, and also more. So because this have the scale, so at least. So just here the 1-to-1, so is defend the 30 meter just the wave. So that is so is critical for ensure so the system the safety. That means the test so proved so all just FFPV is safe in the North Sea. Yeah. And also the second is to test the power generation performance. So we do the comparison offshore vs onshore. So two sets of 108 watt the modules were tested. The offshore group installed in the tested area, just on sea, yeah, and the onshore blue breast on the nearest the coastline about 1.5 miles away. So using the same model for just the fair comparison. So measure the data show that the offshore PV provide stable power and also DC current, energy output, and DC voltage. Yeah. So here the blue color is offshore the PV, and the red color is on land PV. So it shows offshore is better than on land. So you can find and also just the left and below just the picture shows the blue color. So also is up to the red color. That means the energy generation in offshore is more than onshore. And the next also is important is energy consumption. So important. So comparison data are even clear. So monitoring on July 30 shows the offshore PV total energy consumption is lower than onshore PV. So for example, just the 955. So offshore consumption was 0.05 unit. Meanwhile, so 1.1 unit onshore. So why so cause this difference? So the key reason is the lower flipboard design of TK FFPV. So they are allowing so waves to wash over the modules, so which cools the panels and also provide a safe clean. So this increasing so power output by 5 to 10%. So we already test the safety and also to test just the power generation performance. So next we will talk about is it easy or difficult for construct. So here two videos show the deployment and remove. So the install process is convenient due to the foldable design. So the video shows we can easy and rapidly deployment, and this can help reducing dependence on offshore work windows and also just make the transportation cost cheap. Yeah. So if we want to remove it, just as the right video so show, so we no need the heavy offshore construction such as pile removal or crane lifting. So we just the system can be towed just by vessel as a small boat. Yeah, can make it removal quick and simple. So this video shows we just use the boat so remove all the FFPV. Yeah. So that means this is for construction, so it's easy and simple. You know, the most important is about the cost. So we already show so the 4 examples of China the company. So they build just the you know so the floating the PV. So the just the expensive is to $10 per watt. Yeah. Here we show the EPC cost. So it's 7.95 RMB per watt. So it's about $1 per watt. Yeah. So we also have the table. So as the initial cost is here, also the EPC cost. So for the construction, so it's 7.95. And also the levelized cost of electricity, just the LCOE is 0.31 MB per kilowatt hour. Yeah, it is close to solar energy on land and also sea wind power. So as you know, so the lifetime of just the corrosion resistance steel is longer than PV. So that means after PV, so just after the lifetime, so we have also the use for the corrosion resistant steel. Yeah, and also this material is the main part of FFPV. So we consider if we have the 70% cost after we just the lifetime of PV, so we can reduce in the total EPC cost to 3.5 RMB so per watt. And also the LCOE just decreased from 0.31 RMB per kilowatt hour to just 0.21 to 1. So this means so just for economical, so it's also is very have the advantages of this one. Yeah.
Jismi,
And
kind of reminder,
also, I
Professor?
want just the conclusion. Yeah. So in brief, so there are 4 advantages. Yeah. The first is highly efficient and easy deploy. So the floating system achieves a 1 to 10 the floating ratio. So for example, a unit actually so of the 5 meter long and also 2.5 meter wide. So therefore, they can expand to just 50-meter long and 2.4 meter wide. So can reducing the transport cost easy for offshore work and can be rapidly deployed. And then the second is eco-friendly. So this is optimize the shading prevent the overblocking of sunlight. And also this is just the type, no piles and the fixed foundation are required. Can also reduce the impacts, yeah, for the economical, the controller. So so here for life cycle cost for large scale deploy are estimated that about the 7 RMB per watt for rolling project. So so the for example is the minimum is 12.5 and the maximum is 105 RMB per watt. So it's cheap enough. And also it is international, yeah, adaptable. That means so we can just spread is not only in China. So we have the compact plug and play design. So it's it's quite simple. So allow the exporter just find the shopping containers. So rapidly meeting clean energy. So also we say it's very easy to spread so our technologies. So the finals also thank you. So and we eager to invite you visit China, also visit TIWTD. Also, we want you share the technology of FFPV. So and look forward to build the floating PV in Java Sea. And also so because I have visited Indonesia so many times, more than 100 times. So I already find so there are so large sea area in Indonesia. So that just the maximum wave height is below 4 meters. Yeah, so it's for the FFPV is very good area. Yeah, very good area. So thank you. Selamat datang. Yeah. Okay.
Thank you, Professor Sen Hambao, PhD. Sese.
Yeah, thank you.
Sese. Sorry.
Yes.
For the insightful, the
Sama-sama.
thought-provoking presentation. Sama-sama. Okay.
Yeah.
Ladies and gentlemen, please join me in giving a round of applause.
Thank you.
Ladies and gentlemen, I hope all of participants still fresh during lunch. Finally, we will the last session. Dr. Chi Yi Li from Ming-Chi University of Technology, Taiwan, with the topic Surface Enhanced Raman Spectroscopy shares. Before we proceed, allow me to briefly present the CV or fifth speaker. 2001 PhD PhD National Taiwan University. Assistant Research Fellow, Organic Electronic Research Center of College of Engineering, Ming-Chi University of Technology, New Taipei City, Taiwan. Research specialized in the fabrication of porous template, particularly anodic aluminum film for the development of diverse nanocomposite. Dr. Liu current work focus on advancing substrate technology for surface-enhanced Raman scatterings, aiming to improve detection sensitivity for chemical and biological analyte fossil database management. Now, I kindly invite Dr. Chin Yi Li to begin her presentation.
Okay. Thank you for inviting me, and good afternoon, everyone. My name is Zhi Liu. Could you show me share my image?
Yes, clear your slide.
Okay. Wait a minute.
Yes.
Okay, as everyone can see that.
Very clear.
Okay.
Go ahead.
Yeah. Thank you everybody, and thanks you to the organize the invitation me for to have a chance to introduce my work. So today I will present a talk called Advancing Certain Substrates Engineering from Several Net Structures to Functional Hybrid Designs. In the beginning, next page. Okay. In the beginning, I will introduce the Raman spectroscopy that as a background knowledge. So you can see this image to understand what means the basic idea of Raman spectroscopy. This idea is that when we have irradiated with instant light to some molecule or end light, then this kind of laser light will interact with this molecule, so create its vibration mode. So it basically reflects the vibration mode of your end light or molecules. So that means that instant photons exchange energy with vibration mode, and the scattering light will have information about the vibration mode of the molecule or end light. So this kind of study or the scattering can provide molecular fingerprint information. That means you can use the Raman spectroscopy to identify the molecule or unknown materials or your end lights. So there are two kinds of Raman spectroscopy. One is called stock scattering, the other called stock scattering. Because the stock scattering usually provide higher signals. So in general, we will in this talk I only discuss about the stock scattering in this case. So Raman scattering has many advantages. First, that it is non-destructive analysis. Secondly, is that they have a high chemical specificity, can use to distinguish similar molecular structures, and it can also be used the sample can be used for solid, liquid, and gases. And this technology can be combined with search to enhance sensitivity. Basically, we will discuss the more detail today in this part. Raman spectroscopy have many applications. First, it has a chemical and material analysis for safety and agricultural products, biodetections, and even optical electronic material calculations. Sorry. Next page. Okay. So, what means servicing a Raman scattering? Service. Basically, this is a powerful tool to enhance the Raman signals. So Raman signals has one drawback. Because efficiency is poor, so if your end light is low concentrations or small amount, it does not provide enough sensitivity to detect low concentration materials. So this servicing and Raman scattering is a tool that can enhance Raman signals by more than 10 order magnitude. So it can improve the drawback of Raman. So basic search have two kinds of mechanism. First called electromagnetic enhancement. The second is called chemical enhancement. For the electromagnetic enhancement, you can image think by these figures. If you have a metal structures, for example, two silver or gold nanoparticles, the two particles are quite close. In a gap, they have a nanometer scale gap. So by that way, when you irradiate the metal nanostructure with laser light, then in the gap, that means the area between the two particles will provide strong electromagnetic fields. If your molecule or your end light localized in areas we call hotspots, then it reflected the third signal or the scattering light signals will strongly improve. That means the Raman signal from this hotspot is much larger than the Raman signal out of these areas. So this is called surge, serving around scattering. And by this mechanism, the signal can be enhanced by 10 order magnitude. The second mechanism is called chemical enhancement. That means if your molecule or end light attached to the metal net structures. They will have the charge transfers between your molecule or analyte and metal. By that way, you can increase the Raman signal by 2 to 4 order magnitude. So conventional effect, now the third signal can be much stronger than the traditional Raman signals by more than 10 order of magnitude. Because this is also one kind of Raman signal, third is also one kind of Raman signal, so it can be applied for all kinds of applications similar to Raman spectroscopy, but with ultra high sensitivity. So in the past 7 years, we work on the seven scattering is basically to develop of diverse substrates for biomedicine, organic molecules, and pest detection. Here shows several examples. In the first case, we create a substrate called glass AG substrate. This substrate is fabricated simple. We just deposit silver on glass and slide on it and fabricate the substrate. And it can be used for detecting adenine molecule. Adenine is one kind of biomolecule. So you can see signal reduces with the concentration reduced. The same case is also we use glass AG substrate. Use that to detect a pesticide in apple juice. This pesticide is theremin. We can see that apple juice is really practical sample. So this detection just tells us that we can use this substrate to detect the real sample. The third substrate is that we create the AOAG substrate. AO means anodic aluminum oxide, which is a porous materials, and many people use this as a nano template to create all kinds of nanostructure. In here, we use the AO to create silver nanoparticles. So use this as a third substrate to detect molecules, such as rubin 6G, one kind of bimolecular. So in this case, that AO AG third substrate could provide the detection limit, go to 10 to minus 11 more. So it's very low concentration. The final case is that we create a substrate by combining perovskite and silver to create an AG perovskite substrate. This kind of perovskite is one kind of semiconductor, so it can be used to tune in band gap and provide a advantage on the surface. And using the surface substrates, it can also be used to detect pesticides such as TBZ, go to the concentrations of 10 to minus 8. So before I introduce the third subject we developed, we want to tell people that how can we use third subject for high sensitivity detection of pesticide? Because this kind of pesticide is very commonly occurs in all kind of food and even juice. In this case, you can see if we have a juice with pesticides, how can we detect it? Use our third subject. It's very simple that we just take the juice and take a drop one juice with the pesticide on our fabricated cell substrate, then use the source or Raman system to detect the Raman signal in this dropped area. Then we get it. Here shows one example. We detect the ceramine is one kind of pesticide in a convention in a apple juice we purchased from a convenience store. We can see the Raman signal intensity decrease as the concentration reduced like this. For this peak. You can see the peak intensity gradually reduces when the concentration of ceramide reduces. So this case demonstrates that the third substrate developed here can be used for practical applications, and that means we can use that to detect real samples. So here shows a movie. I will show that how can we use the third substrate to detect pesticides in another kind of another drink that is black tea. Okay, see this movie. First, we just take our sample that take one more of Atrodia to the sample that is black tea with pesticides. After that, we are shaking sample with 5 minutes. Then we centrifuge it with 10 minutes under 12,000 RPM. Then we take the sample out and take a part of supernatant. Then we drop the supernatant on our developed search substrate.
10 minutes remaining.
The average joy, we just use the subject to detect Raman signal. In this case, we take a handheld Raman system. That means we can easily move this system to any on-site position. It's easier, it's like an instrument, so we can easily use that to detect anything on-site. And after that, we just measure Raman signal. In this case, it shows that if your sample, then the black tea do not have pesticides. If they have pesticides, you can see clearly search peak. Oh, sorry. This case that shows that the sample without pesticides, and here should the peak is if the sample with pesticides, you see search peak. So it can be used to real case. Or this is with pesticides, is without pesticides. So for that case, that we can also use it for micro Raman. It can be more precisely measurement. The process is very similar, but this is used for the precise measurement for the academia case. Here shows spectrum without any pesticides, so there's no clearly pesticide peak. If we have a sample with pesticide, you will see this peak. Those are the pesticide peak. In this case, is summary. So, but it tells us that this case example just tells people that we can easily use search substrate to detect the pesticides. Okay. Now, I will start to introduce the search substrates we developed. So this file, this case that is glass edge search substrates. This is a simple process. So we just take a piece of glass slide, put it in a thermal diversion system, and deposit silver. This is typical search substrate we created on the surface. You can see many white spots. That means silver nanoparticle. And in this case, that here shows the substrate we use. That this is a real photo image. You see purple area. So basically, this substrate is semi-transparent. So how do we use that? Is as present less transparency. Say that we have substrate created by this way, and drop our sample, and use Raman to measure the search effect. So here's a typical example. We measure 5 times 10 to minus 5 mole serum in orange juice. So it's also a real sample. And this is typical detect signal. You can see all these peaks are from serum. And we can also do statistical demonstrate that there is uniformity. So we take the peak on 13A3 to plot the histogram like this, and this peak. So we said that this is about 48 spectrum, 14 peak. So we can calculate RSD is about 89.9. So that means fluctuation less than 10%. It's quite good uniformity. Okay. In some case that if the search subject does not provide enough sensitivity to differentiate the sample with small concentration difference, then how do by that way we can use another skill that called adding, called internal standard. That means we adding as an example to create a more So with that means we add the solution with the internal standard. You can understand by these figures. This is typical example that you choose with serum. We directly use that for search measurement. But in that case, that we can put internal standard into the solution, then do search measurement. What's the difference? You can see this figure. This figure shows that the case that without internal standard, so we can only detect the search signal of the serum. So you can see, even though the concentrations reduce with the search intensity reduce with concentrations, but in some cases like here, you cannot set the even low concentration signal is high concentration ones. So it's hard for us to quantitatively differentiate the 3.5 times 10 minus 5 mole and 4 times 10 minus 5 mole. That means this without internal standard, the subject does not provide enough sensitivity to separate the different concentrations of samples. But if we add the internal standard of adenine, like this case, we can also see the serum. That means the samples signal. It also reduces with the concentrations of adenine. But you can see that in most cases that their error bars do not overlap. So that means the sensitivity to distinguish plasma concentration ability improve. And we can also use the the adenine peak, that is 732, this peak, and another one is 1322 around here. We divide this peak with corresponding 731 peak and get this two peak bigger. You can see that also shows good ability to distinguish different concentrations of analyte. You can see in some cases, like here, they do not provide enough sensitivity to distinguish the concentration difference, like here. But we have three images. So combine our three images, we can calculate that almost every spectrum, they can find an area that their error bar does not overlap. That means that we can use them to significantly enhance search sensitivity to distinguish peptide concentrations. So now I want to introduce another kind of search substrate that is called perovskite-based search substrate. Prior to introduce that substrate, I want to introduce a material called perovskite. So perovskite refer to a broad classes of materials share the crystal structure of CaTiO3. So basically, it's one kind of materials. In general, even materials with the form of ABX3, where A and DB are cations and X are anion. This kind of materials are called perovskite. So this is a typical structure of perovskite. So here's your example, CSPB-I3 and CSPB-BR3. We are using these two materials in this talk. These two materials, both are metal halide perovskites. For metal halide perovskites, they especially lead halide perovskite possess remarkable optoelectronic properties, including strong light absorption, high carrier mobility, large carrier diffusion lenses, and tumor band gap. Because these materials have such many advantages, so it's making the perovskite highly attractive for LED lighting diodes, solar cell for detector. In this case, we use for surface area scattering. It can also be used for other photonic and nanophotonic technologies. So now I will start to introduce the perovskite-based search substrate in our work. In this case, that we use two kinds of perovskite, CSPB-I3 and CSPB-R3. So there are several work has done in the perovskite-based search substrate as the image shows. For example, this case is from literature. In this case, that they take a PET and they deposit CSPB-BR3 on top. They deposit gold. They use the spore MBA as a probe molecule to detect the substrate efficiency. You can see this image.
Just me, 3 minutes remaining.
Oh, 3 minutes. Okay. So you can see that in this case that you have many kinds of the small peak. If we deposit sample on the silicon, there's no very small peak. But if we use that for gold substrates, you can see higher peak. If you combine with the perovskite, you can get many strong search peak. So in our case, we also develop the search substrate based on the thermal deposition. You can see to create the CaIG substrate, then deposit silver. We use this kind as search substrate and get clear search signal. You can see, as here, is concentration dependence. You can see that the signal reduces with the concentrations. And for this case, we get the LOT of 10 to minus 9 more. Okay, because time limitation, I don't have too much time to say the presentation, so I do not go to the conclusion. Okay, so I conclude in this case that we develop high quality search and peer search substrates. Conventional silver-based search substrate often suffer from a substrate-driven background noise, so limiting the detection of low concentration analyte. To address this, we develop a silver perovskite search substrate that minimizes interference and reduce photo-induced raman scattering in our peers with UV radiation to further amplify signals, like here. So we develop a search substrate like this one, so the signal reduced with concentrations. We also did one process called peers. That means we do the process search measurement before, and we use UV light irradiate substrate, then do the search measurement. Then we get a strong signal like this. So that means we get, if we use UV irradiation, we get strong signal. Without is low signal. Okay, thank you for your attention. I love to answer any question.
Thank you, Dr. Si Yili, for the insightful presentation. Yes. Ladies and gentlemen, please join me in giving a warm round of applause. We will now proceed to question and answer session. Ladies and gentlemen, if you have a question, please raise your hand and I'll type your question through the platform provided. For clarity, kindly state your name and institution before asking your question. Okay, the first question, please, Al Jahwa Meha Zahra. Okay,
Thank you, dear Mr. Chin Liao. Thank you for the insightful presentation and for the opportunity to ask my question. My name is Alzahwa Meha Zahra, a student of the Urban and Regional Planning Study Program at Pakuan University. My question is, in the context of climate change, what resilience strategies should cities prioritize when developing sustainable infrastructure? Thank you.
I'm sorry that your voice it is disconnected. Can you speak your question again? Sorry.
Okay.
Please
My
repeat
question is,
Jawa.
in the next context of climate change, what resilience strategies should cities prioritize when developing sustainable infrastructure?
I'm not sure that I understand your question. That you mean that what next development of what I saw I lost your question that because that the internet seems that does not show very clearly. So can you just give me some hints of the key words that because I cannot really hear what is your question. You want to ask the development of what?
Maybe Al Jawa, can you repeat the question in order?
Sorry, your voice is also disconnected. From my part. Sorry.
Al Jawa. Al Jawa, please repeat your question in order more clear.
Sorry, I lost your voice.
Okay. Okay. Please write through the column chat. The next question, please.
I'm sorry.
Mr. Bloko, please. Question, brief, short question, please.
Okay, thank you. I have two questions to Prof. Chen. My name is Bloko Budi from Electrical Engineering, Pakuan University. And my question first, what does the movement of waves affect on the electrical output and energy yield of photovoltaic arrays? Question number one. And the second, what challenge arise when transmitting power from an ocean-based floating photovoltaic platform to onshore substation? That's all. Thank you.
Thank you. Maybe not very clear, but so so for offshore floating PV, so to just the wave, so the PV is the solar energy. So also just to offshore. So so PV also is soft, not as just the hard one. So as for the floating, as the ocean engineering, So we should to face to the ocean side. So the first is defense the wave. So we just the coast and also the structure. The first the concept is the wave problem, wave problem. So so just as the example of Java Island, The south of Java is just in the ocean. So there is just the swell, just the Rough Sea. So the maximum wave can reach to more than just the 6 to 7 meter, yeah, with time. But for Java Sea, so just north of Java Island, so as just the Jakarta, so north of Jakarta. So here is about 2 or 3 meter the wave. So first the difference is the wave. So so if we just to construct the floating PV, so as in Java Sea, so we face to is just as the smooth surface of the sea, so that will also can be cheap. The structure is not so too strong, but so the cost of structure is the maximum the cost of the floating PV. Yeah, so that means so in Java C, so we just use all type FFPV. So the cost is quite similar with just on land just the solar energy. So it's have very high economic so we can to just use it. Yeah. But to as the strong wave as the south of Java Island, so in the ocean, so now is also the very big challenge for that. So the first we just selected of that one, yeah. So for the economic, just the so the fact of economic, yeah. So maybe not direct to your question. Your second question is what the next the second question?
Challenge, Prof. Challenge. What challenge arise when transmitting power from an ocean-based photovoltaic float photovoltaic platform to onshore substation? What's the challenge arise when transmitting power from the ocean to onshore substation?
Sorry, also not very clear. Yeah. So your main just the comparison between the onshore the PV and also the offshore PV is the what the technology are the different of that one. So not very clear your question. Yeah.
Okay. The question is how the transmitting power from the ocean to substation in onshore or on the land.
Oh,
Maybe.
I know. Just the power from offshore to onshore. Yeah. So also is now is use the line. Yeah, the line also also is a bigger problem. So sometimes the distance from offshore to onshore is very far away. Yeah, far away. So we just use as the cable. So just underwater.
Underwater.
So yeah, but so for in Indonesia, maybe this is not very difficult, not very difficult because as the Java Sea is calm and also the material, the sea bottom is just is the muddy, yeah. So it's easy to just to do that. But so now we have another way of that one, So we just to use the power so on sea, so so to the water, we can just to use the power to the H2 and the O2, yeah. The oxygen can just to to make the water, yeah, and will help for fish, and also use the clean the chemistry power, yeah, from that. So that will just the less of the cable, no use cable to transport the power. But I think for Java C is easy. Yeah, it's easy. Use just the underwater cable. Yeah, from offshore to onshore. Yes.
Okay. Thank you, Prof. I think enough and very interesting topic and very insightful. Thank you, Prof.
Yeah, thank you. Yeah.
Thank you for the last question Please, Fahri M. Juhdi. The short question, please, Fahri.
All right, so greeting everyone. Once again, thank you for the opportunity to ask. So my name is Fahri Muhammadzudi from Civil Engineering Fakultas Pakuan, Fakultas Teknik Universitas Pakuan, Indonesia. So I have a question for Professor Chen from Tianjin, China. So I'm interested in for the structure aspect itself. So since you mentioned before that the prototype is, the modeling is use the steel instead of plastic or other materials. So how can the steel itself can maintain or like how long the structure can last for, like for many years or how many years? Because I think the foldable system, the foldable mechanism, it can be the new weak point for the structure itself. So that's the question. Thank you.
Okay, it's a very, very good question. So also including the cost, including the cost is related with the lifetime. So we talk about the material, just the steel, the lifetime. So we first talk about just the PVE, just for the solar energy. So we have now the lifetime have just the two, just the answer. Why is for just the good lifetime is about 15 years, 15 years. Because for now the technology of just the solar energy, so limited. And also we can extend the lifetime is 30 years. But so for the steel, for this steel, just the use in ocean as in sea, the condition. So now is also already verified is more than 50 years, more than 50 years. So so why? So we consider after the lifetime of PV, so the steel can be used, can be used. But so the material also different with the quantities, So sometimes the steel is 50 years. So maybe if we not very good, so only maybe 20, 30 years, So that's why we also should select the good one, Thank you,
All right, thank you very much.
Okay, thank you. Ladies and gentlemen, this question and answers close session, and then I want to be briefly summarize the key point from the today's session. From Chen Hanbao, PhD, the rapidly deployable foldable FPV system mark a pivotal advancement in offshore energy, spearheaded by Professor Chen Hanbao at the Tianjin Research Institute for Water Transportation Engineering. By solving critical logistic barriers with the unique foldable design, CWT has successfully combined rapid plug-and-play development with the hydrodynamic stability requirement for harsh marine environment. This achievement by China's Ministry of Transportation effectively unlocked the ocean vast potential, making large-scale offshore solar commercially viable reality. From Dr. Si Yi, integration of silver with perovskite semiconductor grid reduce background noise. This substrate achieves a very low detection limit for Raman detection. The innovation support practical use in pesticide monitoring and food safety. Overall, the technology forms the foundation for next generation high-performance Raman detection system. Ladies and gentlemen, our speakers have now delivered their presentation. We have reached the end of presentation session. Now, I would like to hand the program back to our Master of Ceremony, Mrs. Yusi and Mr. Swinda.
Okay. Thank you very much, Dr. Rian, for guiding us to such a productive and insightful session. Distinguished guests, esteemed speaker, and participant joining us from around the world, I now resume my role as your Master of Ceremony. On behalf of the organizing committee, we would now like to present certificate of appreciation to our speakers and moderators for their valuable contribution to today's session. We kindly invite all participants to remain with us as we proceed with the certificate presentation. First, we would like to present the certificate to our speaker, Dr. Huang Seng Huang from Sun Yat-sen University, China.
And next, Sir Dr. Mohsahmi bin Shahid from University Technology Mara, Malaysia.
And next, Associate Professor Dr. Siti Hajar binti Misnan from University Technology Malaysia.
You're
welcome.
Thank you.
And Professor Jack Hambao, PhD from Tenji Research Institute for Water Transport Engineering, China.
Terima kasih. Thank you.
Sama-sama.
谢谢。
谢谢. And next, Dr. Chi Yi Liu from Mingji University Technology, Taiwan.
Thank you.
We would also like to extend our appreciation to our moderator, Dr. Rian Nurtiawan, STMT, for expertly guiding today's session. Thank you for being part of ICONES 2025.
Ladies and gentlemen, we have reached the end of today's conference. On behalf of the organizing committee, we would like to express our sincere gratitude to all speakers, moderators, and participants for your active involvement and contribution. We hope this conference has inspired new ideas and strengthened collaboration in sustainable infrastructure and smart city innovation. Please don't forget to fill out the attendance form to receive your e-certificate. Thank you all for your attention. See you in the next ICONES 2026. Have a wonderful day, stay healthy, and stay inspired. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you.
Recording stopped.